Alright, hello everyone. This is part 2 of learning SAT and taking you guys along on the journey. So, I'm doing these hard SAT math questions again. We'll try to do 5 of these today since I did 10 and the video was a bit too long, so we'll go for 5 today. Try to keep that consistent. I'll also make English videos if you guys are interested in that. Let me know. But yeah, these are pretty much for preparing the SAT material myself and taking you guys along it if you want to do the same. So let's start with the first question. The question says, let m be an even integer. Okay, so that is something that the problem statement has told us. It's going to be even. And then they're saying how many possible values of m satisfy under root m plus 3 is less than or equal to 3. So immediately let's just solve this. We'll square both sides. So once we square both sides, what we should get is m plus 7 is less than or equal to 9. Right, and then you're going to take m and subtract this on the other side. Then what you'll be left with is 2. So m is less than or equal to 2. This is one of the things we know. I think there is another aspect to this question as well. We have m plus 7, which is in an under root. So we know that this m plus 7, we know that this has to be greater than or equal to 0, because if it's less than 0, it would be an imaginary number, and that is something that we're just not accounting. So as far as I can tell, you'll have to do m plus 7 is greater than or equal to 0, and that's going to give us m is greater than or equal to minus 7. So if we combine both these values, we're going to be getting m is greater than or equal to 2, and it's greater than or equal to minus 7 and less than or equal to 2. So basically the solutions could be minus 7, minus 6, minus 5, minus 4, that's where we stop. So they've told us that it has to be an even integer, so immediately we can cross out all the numbers that are odd, and so we'll just cancel out minus 7, minus 5, minus 3, minus 1 and 1. So if these are crossed out, the only numbers we'll have left are minus 6, minus 4, minus 2, 0, and 2, which are 5 numbers. So our final answer should be E, 5 numbers. That should be pretty much it. We'll just move that aside, and let's see the next question. Okay, so it says, let x be defined by x is equal to x plus 3 over x plus 1 for any x such that x is not equal to 1. Okay, why do we know that? Because the denominator over here, the function would break, you would have infinity, so you cannot have the denominator is equal to 0. And if the denominator is not equal to 0, then you'll have x is not equal to 1. So we already knew that, but they still specified that for us, which is nice. So now what they're saying is, which of the following is equivalent to this? X minus 1. All right. So I believe what they're looking for is, basically they've put it in a box. So as far as I can tell, we'll have to do this whole thing, which is x, right? They've already specified that. And then we'll subtract 1 from it and then find the answer like that. As far as I can tell, that's what you'll have to do. Let's just see if that works. We'll add the like terms. We're going to get 2x plus 2 over x plus x minus 1. Yeah, that's what we have. Let's see if there's an option that matches our answer. I don't see one. So if we take 2 common, let's take minus 2 common. So if we take minus 2 common, we'll have, no, that doesn't work. Let's do 2 common, so you're gonna be left with this over x minus 1. Do we have an option like that? Not really. Maybe we have to rationalize. Let me see. Oh, I see the problem. So we're subtracting it from 1, and when I wrote it in the numerator, what I did was I mistakenly wrote it as plus. So basically it's not plus, it's minus over here, and that's going to change everything we do from now on. So we'll just rewrite that. We'll have x plus 3 and then minus x and minus 1, so plus 1, yeah, and then divided by x minus 1. And now what we'll have is, we'll have x is gonna cancel out, we'll have 4 in the numerator and x minus 1 in the denominator. So our answer should be, yeah, it should be B. There we go. Okay, it makes sense. I just made a silly mistake doing this. Yeah, I have to avoid doing that, but it is what it is. Anyways, let's move on to the next question, which says let a and b be numbers such that a cubed is equal to b squared. Okay, so which of the following is equivalent to b under root a? All right, so I believe basically we'll just write this. Okay, got it. I got confused for a second, but basically you can write this a, substitute b squared for this. So once you do that, what you'll be left with is basically it's b squared, so square is going to cancel, and then you'll be left with b times b, and when you're multiplying same basis, your power adds. So this is just going to give us b squared. As far as I can tell, it should be c. There's no other way, I guess, to solve it. Or wait, did I make a mistake? Let me see. So it's under root a. Oh, right. So the relation they've given us, that is of a cubed. So for a, we would have cube root of b squared. Yeah, that's what we're gonna have in the value for a. So we'll just replace that in there. We can rewrite this over here as b raised to 2 by 3. So we'll just do that. We'll multiply with b raised to 2 by 3. And once we have that, again, we have same basis, we're just going to add the powers. And then this is going to become, let's just do it on the slide. So if we have 2 by 3 plus 1, this should give us 2 plus 3 over 3. That's going to be 5 by 3. But that's not an option. What did I do? Oh, I see. Okay, so it's an under root over here, so we had to write that as well. My bad. I don't know what's going on today. Can't focus for some reason. Anyways, so what we'll have is, we'll have b raised to 2 by 3 raised to 1 by 2. This 2 is going to cancel. We'll be left with b into b raised to 1 by 3. Yeah, 1 by 3, and then you're just adding 1 plus 1 by 3. That's going to be 3. 3 plus 1, that's going to give you 4 by 3. So we'll have b raised to 4 by 3 as our final answer, which should be b. Yeah, I think that's correct now. Yep. Alright. If you guys are enjoying seeing me struggle, let me know and I'll keep making these videos. It's giving me a reason to study as well, so win-win. All right, so the fourth question is, let M and M, that's a tongue twister. Let M and N be positive integers such that 1/3 of M is N less than 1/2 of M. Oh my god, okay, so that's crazy. Okay, let's just try to decode whatever they said. They're saying to find which of the following is the possible value of M. Okay, so first of all, let's just try to understand what they said. They said M and N are positive integers. Okay, that is fair enough, that makes sense. Now they're saying such that 1/3 of M, so 1/3 of M is, okay, wait, 1/3, so we'll just write that down. 1/3 of M is, I think this is what we have, don't we? So basically, such that 1/3 of M is N less than 1/2 of M. I think that's pretty much it. Yeah, that's what we have. So now they're saying what is one possible value of M. Okay. Alright, doesn't really make much sense right now. Let's just write it in terms of N and see from there what we can do. So it'll be 1/2 of M minus 1/3 of M, and once we'll simplify that, let's take the LCM. We'll have 6 over here. We'll have 3M minus 2M, right? Which is going to basically become 3 minus 2, it's going to be M, so we can write this as 1/6M. Let's see, so this set was just the following possible. Oh, I see. Okay, so the hint was in the first part of the question. M and N are positive integers. So now that we have this relation, we know that N is a positive integer, and the only way that N can be a positive integer is if M is completely divided on 6 to give a whole number, right? So that means M needs to be a multiple of 6 as far as I can tell. So let's see. So this is not a multiple of 6. Neither is this. 24 is a multiple of 6. 26 isn't, and 28 isn't. Okay, I think that's pretty much it. Yeah, because this applies on this as well. Whenever you're stuck, just do the process of elimination. You'll probably get to the answer. I think that should be it. Okay, here's the last question. So what we have is, if A and B are numbers such that A minus 4 into B plus 6 is equal to 0, then what's the smallest possible value of A squared plus B squared? All right, let's see. Okay, so let's just so from this statement over here, what we see is yeah, from here we can see that A will be 4 and B will be minus 6. This is pretty obvious, right? From here you can just set each bracket equal to 0 and you'll get it from there. Now if we, let's see, we have to do A squared plus B squared. Okay, if we replace it in here, what are we going to get? So this should give us 4 squared 16 plus 6 squared, it's going to be 36. It's gonna guess 52. Is that the answer? Doesn't really make sense though. Oh wait, I think I got it. Wait. Okay, so I guess because we have this whole thing equal to 0, what we can do is, yeah, so basically if this is equal to 0, one of these factors has to be equal to 0, right? Because then you're multiplying with that and that's going to give you 0. So let's just say if a is equal to 4 over here, yeah, if a is equal to 4, okay, I don't like this question. What? Maybe it's a simple solution, I'm just overlooking it. Okay, let's just look at this again. If a and b are numbers such that this statement is true, then what's the smallest possible value of this? Okay, I know that has something to do with these over here. What exactly though? Oh wait. I think this might work. So if we let a as 4, okay, so a would be, if a is 4, in that case this factor would be 0, right? So we let b as the minimum possible value we can let it be as, which would be 0, right? That's gonna give us 16. Is that right? I think that's yeah, and then if we do the same thing and then we let b equal to -6, that way this other factor would be 0, then we can do that same thing for this too, which would then become, we let a as 0, and then we're gonna add to it -6 squared, which would give us 36. So the answer is going to be 16. Let me check the answer key. Yeah, that's pretty much it. So I think that's it. This was definitely a weird question, or maybe I just got stuck on it for some reason, but yeah, the rest of them were still doable. These weren't too bad. This was a weird question. Anyways, yeah, that's pretty much it. I'll see you guys tomorrow for the next 5 questions. Until then, do your SAT prep if you're also preparing, and if not, I don't know, have a great day. But yeah, that's pretty much it. I'll see you tomorrow.